Today we are going to look at the moving stage upon which the drama of Earth history was played out. Geologists call this subject plate tectonics, and you will find out why this name is appropriate in the next 5 minutes. Let's return to our earlier picture of the structure of the Earth. We saw that it consists of the inner core, the outer core, and the mantle. And we saw that there are convection currents within the outer core and the mantle. These produced the early volcanoes and released the atmosphere of the young Earth. Now we will look at the thin scum of hard, fragile rock which formed on top of the mantle. This is called the crust, shown here in red. Notice how thin it is compared to the rest of the Earth. It consists mostly of a layer about 10 kilometers thick called the oceanic crust. Because the rock is cold, it is hard and rigid. As we will see later, this hard rock is pushed and pulled around by movements in the mantle. As a result, pieces of oceanic crust often collide. The result of these collisions is to make thicker, lighter rocks which float in the mantle like icebergs. Some of them stick up above the oceanic crust to form mountains, but most of them float in the mantle below. These blocks of rock are the continents, and they form the continental crust, which is about 70 kilometers thick. Rain runs off the continents and forms oceans on top of the low-lying oceanic crust. Hot liquid rock called magma rises up from a chamber in the mantle. It forms long cracks in the oceanic crust. These are called mid-ocean ridges. The magma then spreads out sideways and cools, creating more oceanic crust, which pushes the original crust apart. So two large sheets of oceanic crust move away from the mid-ocean ridges. As the two sheets of oceanic crust spread out, they carry lighter rocks along with them. These light rocks, for example, are the remnants of the early volcanoes, and they stick up out of the ocean, forming continental crust. This process is still continuing today and is called continental drift. Sometimes two sheets of oceanic crust collide. One of them can slide under the other. Typically, oceanic crust will slide beneath a piece of continental crust because it is lighter. This is called subduction. Earthquakes are common as the oceanic crust sinks back into the mantle. Friction also creates heat, which melts the oceanic crust and perhaps also the continental fragment, creating volcanoes at the edge of the continent. This is how the Andes Mountains are being formed today. Sometimes two continents collide. Their edges are crushed together and new mountains are created. That is how the Alps and the Himalayas were formed. The map of the continents has changed over time, and this has had effects upon the climate and on the evolution of life, for example by creating new environments which living things can exploit. This is the moving stage upon which the rest of our story will be set. The result of continental drift has been that the crust today is subdivided into about 12 slabs called tectonic plates, which have evolved over history and are still moving, colliding, subducting, making new mid-ocean ridges, new volcanoes, and new mountain ranges. If you're interested in the history of the universe, you might like Time Crystal, which takes the characters back to the Big Bang and beyond. The first volume is called The Illustrated Cosmic Monopole. Visit timecrystal.co.uk.